Hey guys, this example 8 pretty much captures everything from sections 11.1 and 11.2. So the first half of your test is pretty much caught up completely in this single story problem. So first, let's see what we're talking about. The table shows the prices of 8 mountain bikes in a sporting goods store. So we have the price in dollars from several different stores. Okay, we're going to analyze our data. First, they asked us to find the mean, median, mode, range, and standard deviation of everything here. So for part A, we're going to find mean, median, mode, range, standard deviation. Okay. Well, I told you guys before, you can use Desmos. You could do all these by hand if you want. I would not. I would go to Desmos, X out of everything. Put in a new table, and then now that we have our data in, let's just let the calculator do the work, because we're going to have other work to do now besides that. The mean of x1, the median of x1. We are going to have to find the range and the mode ourselves. But I can go right here and also put in the standard deviation for x1 right now. So while I have this up, I'm just going to go ahead and write in those numbers. It'll look a little jumbled for a second, but after I get this done. The mean was 122, the median 109.5, the mode range, I'm going to have to find the standard deviation 36. Now I need to go back and look at my data sets to get the mode and the range. So did any number appear twice? It looks like 98 did. The range is our max minus our min. The most expensive bike was 211. The cheapest bike appears to be 95. So 211 minus 95, 116, right? I'm just checking my math. Yeah. And again, I would do that on a calculator. I need to do it on a calculator because I don't want to be embarrassed in front of everyone on video. So 211 minus 95. Good. All right. So now we just completed part A. Part B, identify the outlier. An outlier is a number that sits outside the data. There is a very specific mathematical way to measure an outlier. It is 2.5 standard deviations from the mean. I have gone over that in class briefly, but for us, our outliers are going to be very specific and very obvious. As I look up here, it's pretty easy to see this number does not fit with the rest. It's not even close to the rest of the data. So the outlier is going to be 211. Okay? Now that I know what the outlier is, I want to analyze what that outlier will do to my data set. It's got 3 things it can mess with. The mean, the median, and the mode. Now, we went over this several times because when you have an outlier, it changes which measure of center you want to use. Mean is our favorite. It's our favorite unless there's an outlier. If there's an outlier, then we go with median. We pretty much never use mode. So mean, what it does is it drags that mean. The outlier will pull that mean towards it. Since the outlier is big, it will increase the mean. If the outlier was small, it would decrease. But what does it do to the mean? It will increase the mean a lot. What does it do to the median? It will still increase the median, but not near as much. So we'll increase the median a little. And then the mode, it has no effect. Okay. And how about I use proper English? Effect, not effect. Okay. So the mean, an outlier messes with a lot, the median a little, the mode not at all. And when it changes it, it pulls things towards it. So if your outlier is on the large end, it increases. If it's on the small end, it will decrease. Okay? That takes care of part B. Now we have to make a box and whisker plot using the data. Well, we already put everything in X1 here for the data. So now we can just go through and do everything we did before to find Q1 and Q3. Okay? So this time, I'm not going to get rid of the mean because I need it. I'm not going to X this out because this is the data set I'm using. But I can come in, minimum of X1. I want to find quartile from my X1 data set, and I want it to be the first quartile. Then I already have the median from before. I want to find my quartile 3 from my data set X1. And I also need to know my maximum. So there's my median. We already had that. And now I can see all my information. So I'm just going to write this down for C. I have a minimum, a Q1, a median, a Q3, and a maximum. I'm writing them in order so that way it'll be much easier for me to draw my box and whisker plot. My minimum was 95, my Q1, 98, my median was 109.5, my Q3 was this one, sorry I have all this stuff in the way, but I need to keep that, 127.5, and then my maximum was 211. Now we've already gone over how to do box and whisker plots, but we can do one more. If my minimum is 95 and my maximum is 211, going by 10 seems to be appropriate again. So I'm just going to draw a long line and go by equal tick marks, try to make them pretty equal. Then if 95 is my smallest, we can start at 90. So it goes from 90 up to 220. Now I can fit everything in. Put your 5-number summary in. My first one is at 95, then at 98, then at 109.5, then at, 127.5, and all the way down here at 211. So I made my box and whisker plot, and you can see why that's called an outlier. Look how far over there that 211 is. And let's see what they ask us here to do. Find and interpret the interquartile range of the data. Identify the shape of the distribution. So some terminology we have to remember. Interquartile range. Range is from smallest to biggest, but this isn't just regular range. This is interquartile. We have 4 quarters. Remember, that's what this does, breaks up into 4 groups. The interquartile is the inner 50%. So from here to here, because median's right at 50%, right? So the interquartile range is Q3 minus Q1. In this case, it is 127.5 minus 98. Use a calculator. 127.5 minus 98. 29.5. So our interquartile range is 29.5. Now we have to say what that means. Remember, interquartile range, don't come up with any new ideas. Don't try to over-explain it. Interquartile range is the inner 50%. All we know is the spread of the data of the inner 50% is $29.50. So the inner 50% of the bikes are within $29.50 of each other. That's all this number means. Don't go beyond that. So again, what does interquartile range means? The inner 50% of all the data is within $29.50 of each other. That finishes out. Oh, and the shape of the data, this is just like the last thing we looked at. If we look and we have whiskers on each side, it was pulled this direction, right? This whisker is way longer than that whisker. So I would call this skew right, because the right whisker, or you can think of, the tail is still longer. The rules don't change just because we're looking at a different data display, whichever has the longer tail, okay? Now let's go on to by far the hardest part of this, D. If you get everything except part D, you are looking to probably get at least a high C or a mid B, maybe a low B on the test. Now, find the mean, median, mode, range, and standard deviation of the prices when the store offers a 5% discount. So we looked at changing data sets in class. If you have a data set, you can add or subtract to that whole data set. It'd be like if I increase the price of every bike by $10, what would happen to all of my numbers? Or you can multiply every number in the data set. Let's say I doubled the price of every bike. This means the data sets change, but not everything changes. So we had the 5 things we were looking at. We were looking at mean, median, mode. In other words, our measures of center. And then we were looking at range and standard deviation. In other words, our measures of variation. Now, if I add or subtract to the entire data set, only the mean, the median, and the mode change. And see if this makes sense. You pretend my hands are the data set. Variation is the spread. So how far apart, or what is the spread of my hands? If I add to the data set, I simply shift it. Notice how my hands didn't move at all? They didn't go apart or any nearer? That is adding or subtracting to a data set. Yes, because the mean, median, mode are inside the data set. All of them are added or subtracted by whatever you change the data set by. If you multiply entire data set, it shifts like this. You see how my hands spread apart? It changes the spread. So if you multiply a data set, you change everything. So those are your rules. And you have to know this. This can be asked as a check all that apply question. I could say, if I add or subtract to a data set, please check all that apply, that will be changes. That is almost a question I can guarantee on your error test. It'll be one of these, and they're going to say, check that all apply, and they're going to make you answer it to each one, and it's all or nothing. You either get them all right or you get them all wrong. So here's the trick, though. Sometimes they're not straight out. Sometimes they'll just tell you, add 10 to the data set. Okay, I go here. Multiply the whole data set by 3, or multiply the whole data set by 0.2. Well, that's very straightforward. This question right here is not as straightforward. This question says every store is going to offer you a 5% discount. Or let's just say you have a 5% discount on a certain type of bike that's at every store. So you're going to be able to take 5% off of the original price, which these were all of our measures of center on original prices. So if you are saving 5%, you got to shift your mind here. Don't think how much we're saving. Think how much we are paying. So we are saving 5%. That means we are paying 95% of the original. So what is happening to every number in our data set? We are taking 95% of all of those numbers. That will be the new price of everything. So it's going to be 0.95 times the original. Now it's very obvious. Are we adding or subtracting, or are we multiplying? We are multiplying. But when you're dealing with percents, I'm not multiplying every number in the data set by 5%. That's not what I'm doing. I am multiplying every number in the data set by 95%, because that's what I'm going to pay. I'm not paying the 5%. I am paying the 95%. So as I go through this, we're going to have 0.95 times the original. Well, as we saw before, now we're in part D. When you multiply every single number. So you just go to your calculator. Here are our originals. Our new, or our adjusted for 5% discount, mean, median, mode, range, and standard deviation is just going to be the original times 0.95. So 122 times 0.95, 115.9, or $115.90. Our new median, 109.5 times 0.95. Round it to the nearest penny, so it'd be 104.03 cents. The mode, 98 times 0.95, 93.1, or $93.10. Our range, 116 times 0.95. It's probably getting pretty boring to hear me say that. $110.20. Our standard deviation, 36 times 0.95, $34.20. So again, that is by far the hardest problem that we've seen so far. And it comes down to this. Understanding, if it's a discount, you subtract it from 100%, and that's your multiplier. If you're raising it, it's above 100%, and that's your multiplier. If it just tells you to add, subtract, or multiply, or divide, no percentage involved, you don't have to worry about this. You just do what it tells you, okay? Good luck on this, and you guys can do it. Just review this a couple times.